Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm Victor, and joining me as always is the brilliant Sheila. Today, we're diving into the fascinating world of multithreading models. Sheila, why don't you kick us off with a brief overview?
Absolutely, Victor. Multithreading models are essentially different ways operating systems manage and implement threads. These models determine how user threads are mapped to kernel threads, which has significant implications for performance and resource utilization. Today, we'll be exploring four main models: many-to-one, one-to-one, many-to-many, and the two-level model.
Great introduction, Sheila. Let's start with the many-to-one model. Can you explain how this works?
Certainly. In the many-to-one model, many user-level threads are mapped to a single kernel thread. Imagine a busy restaurant kitchen where multiple chefs, user threads, are coordinated by a single head chef, kernel thread. This model is simple and efficient in user space, but it has a major drawback. Can you guess what that might be, Victor?
Well, if I'm thinking about that kitchen analogy, I'd say the main issue is that if the head chef gets stuck on a complicated dish, all the other chefs are left waiting. In thread terms, this means that if one thread makes a blocking system call, all threads are blocked. This can significantly impact the overall performance of the application. Is that right, Sheila?
Spot on, Victor. That's exactly the main limitation of the many-to-one model. Now, let's move on to the one-to-one model. In this approach, each user thread is mapped to a kernel thread. Going back to our kitchen analogy, it's like having a separate coordinator for each chef. This allows for true parallelism on multiprocessor systems. However, there's a trade-off here. Can you think of what that might be?
Well, while having a coordinator for each chef sounds great for efficiency, it also means you're using a lot more resources. In thread terms, creating a kernel thread for each user thread can be quite expensive in terms of system resources. This might limit the number of threads an application can create, right?
Exactly right, Victor. That's the main drawback of the one-to-one model. Now, let's talk about the many-to-many model, which aims to address the limitations of both previous models. In this model, many user-level threads are multiplexed to a smaller or equal number of kernel threads. Think of it as having a team of head chefs, kernel threads, coordinating a larger group of chefs, user threads. This provides the best of both worlds. It allows for true parallelism without the resource overhead of the one-to-one model.
That sounds like a great compromise, Sheila. But I'm curious, how does the operating system decide how many kernel threads to create in this model?
Great question, Victor. The operating system can dynamically create and destroy kernel threads as needed, based on the application's demands and system resources. This flexibility is one of the key advantages of the many-to-many model. Now, let's briefly touch on the two-level model. This is similar to the many-to-many model, but it also allows for a user thread to be bound to a kernel thread when necessary. It's like having the option for a chef to work directly with a head chef for a special project.
That's a helpful analogy, Sheila. Now, as we wrap up, could you summarize the key points that our listeners should remember, especially if they're preparing for an interview?
Certainly. Remember these key points. 1. The many-to-one model is simple but can suffer from blocking issues. 2. The one-to-one model allows for true parallelism but can be resource-intensive. 3. The many-to-many model offers a good balance between parallelism and resource usage. 4. The two-level model provides additional flexibility on top of the many-to-many model. When choosing a model, consider the application's needs, the available system resources, and the required level of concurrency and parallelism.
Excellent summary, Sheila. And that brings us to the end of today's episode on multithreading models. We hope this discussion has given you a deeper understanding of how operating systems manage threads. Join us next time as we continue our journey through the world of operating systems. Thanks for listening to Operating Systems Crashcast.